This is flip number 1 for Chapter 14, Water Pollution, and you'll notice that many of the slides on this presentation are actually repetitious of stuff that we've already learned about. So what we're going to do is go ahead and kind of eliminate some slides, skip over them because we've already gone over them, okay? So the first thing I want to talk to you about is basically water pollution, and it's basically the contamination of streams, rivers, lakes, oceans, or groundwater, and the contamination comes from humans, most likely, and there's also some naturally occurring pollutants that get into water through things like oil seeps and things like that might be in the bottom of the ocean that just naturally come out of oil reserves in the bottom of the ocean. We've already learned about point source and non-point source pollution. Point source is one where you can actually find the origin. You can find where it was produced, whereas non-point source pollution is one that you can't trace back to the source. As far as which one of these is easier to regulate, it is definitely point source pollution, because point source pollution we can actually manage it through EPA mandates and things like that. Non-point source pollution, the best way to target that is through education, because most non-point source pollution comes from residential areas. And so if we know that what we live on, which is the land, is connected to the water, then that would give us a greater appreciation for regulating what we do on land, so that we do not impact the water negatively. So there's a lot of this stuff we've already gone over. BOD and DO you guys already know about. You already know about the dead zone in Lake Erie. You already know about eutrophication, and one thing I want you to make sure that you know of is the fact that eutrophication is a natural process. It's a natural aging of a lake. When a lake gradually fills in with sediments and nutrients allow for algal blooms, and the algae dies, falls to the bottom, and starts to fill in the bottom. It's a natural process, but we have actually sped that up through what we call cultural eutrophication, which is an increase in the fertility of a body of water, an increase in the erosive nature around the body of water, filling it in with sediments at a faster rate than normal background eutrophication rates. And it's all because of our land use practices. You definitely need to be familiar with different types of diseases that we find in watersheds as a result of unsustainable land use practices. And those diseases include cholera, typhoid fever, the stomach flu, diarrhea, cholera, hepatitis, just to name a few. And so a lot of times rivers will be classified as their disease carrying capability. And so you want a very low disease carrying capability type of river to recreate in, because otherwise if it has a high degree of disease carrying, that means that it's definitely contaminated and could most likely contain one or more of these diseases listed here. We actually have waterborne pathogens that are somewhat as indicator species. And so those indicator species regarding the disease carrying capability of a stream. So this is kind of the antithesis of what we learned about regarding indicator species with macroinvertebrates. You know, like stoneflies and caddisflies are macroinvertebrates that are present in very healthy water. We also have the opposite end. We have organisms that are in water that, if they are present, indicates that the stream is contaminated with disease. And so the poster child organism is fecal coliform bacteria. And fecal coliform bacteria is a type of bacteria that we find in the intestines of vertebrates. So it comes out through waste, and that waste can run off into the streams when it rains, and then it basically allows for that bacteria to exist in the body of water. They are potentially harmful because they are associated with sewage that could end up into the water. Now, there's ways that we manage our sewage, and we manage our sewage through either septic systems or sewage treatment plants. And sewage treatment plants are in areas that are primarily have been urbanized, and you have neighborhoods, you have lots of people, you have high density, and so as a result you need to manage all of that waste from all of those individuals. So we have toilets, which then flush, then go to a sewer line, which then goes to a sewage treatment plant. So what I want to do here, if this will let me, is it's not letting me draw. So what I want you to know is the trace of the waste from our home to the wastewater treatment plant. So what we have is waste from our home, and that goes in sewer lines that extend from our home to the street. And once it's in the street, it's actually under the street in its own line. And then those sewer lines go to a sewage treatment plant. Now there's primary sewage treatment, there's secondary sewage treatment, and there's tertiary sewage treatment. Primary sewage treatment involves the removal of large debris. So when the water comes into the sewage treatment plant, it's literally like a waterfall. And what we have here is your residential area, as you can see in this picture, and it comes into a sewage treatment plant as like a waterfall. And once it goes through these screens, and these screens will filter out large things. So those large things that they filter out include logs, believe it or not, wheelbarrows, shovels, dead animals, rocks, branches, unfortunately in some cases bodies. So it's pretty awful. Now obviously if they find a human body, then an investigation would follow. But what I want you to understand is the massive nature of a sewage treatment plant and what it takes and what it does, because it's pretty amazing. After primary treatment is secondary treatment. So this water will continue its journey through the sewage treatment plant, through the screens, to secondary. And the secondary treatment involves the use of a pool, and what it does is it allows the sediments that are suspended to settle to the bottom of the pool. Now, those organic debris that I speak of is worked on by bacteria. So if you can imagine a bunch of debris down here, it's sludge. It is worked on by aerobic bacteria. And so in a lot of cases, the secondary treatment has like a jacuzzi kind of thing going on. So there's aerators all over in here. And the reason why they have to have those aerators is because of these bacteria, because they love dissolved oxygen. They're aerobic. So they need oxygen to be able to do their job and break down this sludge or organic matter that's settling out of the water. Once that's settled, then this will be removed from this stream of water and sent off in a truck to a landfill. Okay? Now, to get from here to the truck, a lot of times they remove as much water as they can before they ship it off into the truck. And that is primarily because it's heavy. And so you want to reduce costs because you're going to need to transport this material. So to reduce costs, what they'll do is they will remove the water, and they do that through a heating process. And so that water will be removed, and then what's left is like this ash material. And then after that is tertiary. Now, not a lot of sewage treatment plants have tertiary treatment. Tertiary involves the use of ozone and the use of chlorine to disinfect the water. And so then at the very end, you have this clear glass of clean water. When we used to go on field trips, the guided tour guy would actually drink this water, and just to prove all the work that they do to get it to that point. Obviously then, after it goes through all of this, it goes into a nearby body of water. So in the case where our waste goes, it goes to the Southerly Wastewater Treatment Plant down in the Cuyahoga Valley in Cuyahoga Heights area. It goes into the Cuyahoga River. Now, some people may think this is really gross, but it isn't, because the water going into the Cuyahoga River from the sewage treatment plant has been cleaned. Okay, so it's a good thing. So if we look here, this is just a drawing of what I just described, and then it goes back into the water. Now, if you live further out from residential areas that are dense, like suburban and urban areas, a lot of times homes are not hooked up into the system and need to have their own system, and so that's called a septic system, which pretty much looks like this. It's a thing in the back of the house under the ground, and the waste from the home goes into the septic tank, and in that septic tank there's bacteria that work and digest it, and then that would leach out into what they call a leach field. So this liquid moves through a pipe at the top of the tank and passes through these perforated pipes that distribute the water through this leach field. Okay? Again, the reason why they have their own system individually, house by house, is because they're so far out from urbanized areas that to put in sewage lines, it costs billions of dollars, and if they were to just do that for one home, it's not worth it. So these individual homes have their own type of treatment. Obviously then, septic systems have to get emptied. Okay, so then sometimes you'll see large trucks that are a septic system truck, and what they'll do is they have a huge hose on this, and that huge hose will go into the sewage, the septic reservoir, and it will vacuum out that waste and transport it in this truck to then go to a landfill. Okay, so that's how that works. All right, I'm going to stop there because that is all we need to go over for sewage treatment and septic systems.